If there is single CPU and you have implemented 4 threads, you will still get better response. If you have solved a problem using a program, you want to divide that program into different processes in order to make use of parallelism. It is an inefficient thing to do because processes take more time in memory to create. Now, we have a solution to all of this, and the solution to this is that we don't create different processes in order to make use of parallelism. Instead, in a single program, we make multiple threads. Now, a thread is different from a process only in the fact that it is not created using fork. It is not being run in a separate process. One process will be used to create multiple threads, and those threads will be the property of that process. Those threads will be using much less memory as compared to having separate processes for each of those threads. Google Chrome could, instead of making 3 processes, it could make 3 threads inside the same process. But I cannot argue against Google Chrome for this, because there is actually a good logic behind why they've done it, because threads are normally for features which are smaller or lighter in nature, because the features of Google Chrome, like the renderer or the browser or the plugin, these are really big things, and these are they may be benefiting more from different processes. But threads are, for example, you had a word processing application where the word processing application could be updating the display as you were typing a letter, and it was fetching a data from somewhere, and it was spell checking at the same time, and it was answering a network request at the same time. All of these features are smaller feature as compared to a browser application. So these things, if we create separate processes for all of these, it would be, wasteful. It would be less efficient. It would take more memory. So instead, what do? We make separate threads for all of these. So we make a thread for this, and we make a thread for this, and we make a thread for this, and we make a thread for this. Although all of these features remain inside the same process, there is only one program, but now there are 4 threads, and the benefit that I'm getting from all of this is that all 4 threads can be sent to separate CPU by the operating system. All the threads could see context switching being done between all of those 4, so that all the 4 features could think that they are running in parallel. They would get a feeling that all the 4 features are being run in parallel. From the user point of view, the user would see response in all of these features from the computer, from the program, because all of these are running in threads. If you have multiple CPUs, then it will physically, in reality, run in parallel. All of these threads can run in parallel. We cannot guarantee, by the way, but there's a possibility that they can. And if there is single CPU and you have implemented 4 threads, then you will not get true parallelism, but you will get better response. You will still get better response, right? Because user will get better response from all the features, but you will not get true parallelism. But if you have multiple CPUs, like you have a quad core processor, and it is right now it is absolutely free, just for your application, then all these 4 threads that you have created in your code, by the way, in order to exploit this facility, you must write all of these features inside separate threads in your code.